Today's topic is solar thermal net zero energy equipment and will be presented by John Gross. On the right-hand side of your screen, you should see a control panel. Panes can be expanded or collapsed by clicking on the plus or minus sign on the left side of each pane. You should also be able to collapse the entire side panel if this is a distraction for you during the webinar. If you'd like to go into full screen, which we suggest, click on this icon here. If at any time during the presentation you have any issues, just click on the raise hand icon here, and I'll be able to address you offline. You should see a questions pane on the right-hand side here. This is where we ask that you submit any answers you may have during the presentation. Just as an FYI, everyone, we're going to save questions for the end of the presentation. And any that we can't get to, we will make sure to follow up in our email. Now I'm going to ask you, if you can't hear me now, please raise your hand and I will address your issues. Good. It looks like everyone's set. Before we begin, if you're experiencing an echo and you're using the VoIP, V-O-I-P, audio through your computer, we sometimes find that there's issues with this. So you may want to try calling in using a landline. Again, with cell phones, oftentimes we find that there's an echo as well, which is a distraction. As I mentioned, my name is Leela Pakwongs. I'm a project associate with Build It Green. Build It Green is delivering this webinar on behalf of the Energy Network, which is a local government organization created by the CPUC, which provides resources and assistance to homeowners, businesses, and public agencies planning energy efficiency upgrades. And while the Energy Network serves primarily Southern California, a lot of the information that John has for you today can be applied to the Northern California audience as well. Services that the Energy Network provides include community education and outreach, rebate and incentive offerings, attractive financing terms, and tools to help identify contractors with energy efficiency training. Other resources that help homeowners take the next step towards saving energies are also available. Today's webinar will be presented by John Gross, President of Hydronic Specialties Company and a manufacturer's representative for JTG Muir. Economics and business management. He immediately entered the solar, thermal, and energy conservation industry and worked on every level, including 8 years as a service and repair technician throughout the greater Bay Area, repairing thousands of solar and hydronic heating systems. In 1997, he became a principal at Hydronic Specialties Companies and JTG Muir, manufacturers representatives in high-efficiency hydronic heating equipment and solar thermal systems. Today, he's the president of the company, sharing his industry knowledge from a financial, code, and hands-on what works approach. So with that, I'd like to welcome John Gross to our webinar.
Right now, I'm a manufacturer's representative that sells solar thermal systems as well as water heaters, and we do sell them throughout the state. And so what I'm covering today is largely what happens throughout the entire state as far as the solar thermal and rebate programs, and how it's designed and how we do some things on the solar side. And I will also want to touch base on drought and recirculation systems to try and save water, because that's another issue as far as what the state is confronted with. So this is a typical collector array that you might find at your multifamily project. This one happens to be in Hollister. And I'm also a presenter for a keynote speaker for PG&E up here in Northern California. And after our last presentation a few weeks ago, we talked about taking our solar commercial presentation to Southern California. So look forward to seeing our group in Southern California within about 6 months or so. And Arnold Schwarzenegger, some years ago, created a vision of having, by 2020, net zero energy. But what we're actually finding is, in reality, is that we can only get to net near zero energy. And this happens to be a home that near Carmel that actually is net zero energy. They use solar PV as well as solar thermal and heat pumps to get that. All right, and the overall agenda is the California State Initiative. And for solar PV, that has of the funds, those funds have been utilized. but there's still plenty of money, around $188 million still allocated for solar thermal, and we want to use that up. And the CPUC has recently almost doubled the amount of rebate allocated for solar thermal, and there's 4 steps, but we're still in step 1 for most of California, and I'll get into that a little bit later. And we'll also talk about some unique multifamily commercial system issues, the financing. In the slide deck, you'll see an example that is for a particular job up here in San Francisco, and based on that owner's particular financing and tax structure, this is what he would get back. But just using an example, not as gospel for your particular application. Site analysis, recirculation systems. There's also other incentive programs out there for multifamily owners and developers, which is simply changing out water heaters. But it is a little bit of a process. A lot of what we're talking about here today does actually require an energy engineer because there's a lot of paperwork and nuances when complying with the Title 24 points and so on to maximize your return. The solar electric system, other applications that have been to net zero or near zero. So net zero and near zero can actually be beautiful as well. And here's some collectors hooked up to a relatively complicated plumbing system. And there's some ways to make systems less complicated if we're just doing domestic hot water heating. If we are trying to do space heating, that's when it gets things more complicated and expensive. And I do have experience in all of those areas. There's some examples here. Metering, tie into the solar electric side. All right, so the California State Initiative. I'm up in Northern California. PG&E is my provider, but Southern California Gas and so on participate in the same overall state program. And the accomplishments on the solar electric side is over 1,000 megawatts of PV installed. The lessening in greenhouse gases. Now, when we talk about solar thermal, we have various ways to achieve that. And predominantly, what we use is the flat plate collector and occasionally the evacuated tube and the hybrid or some of these other types of systems for really high temperatures. But for your purposes, probably 90-95% of the time you'll be using a flat plate. And I'll go into where a flat plate is probably best and where the evacuated tube may be a little bit better choice. And the hybrid is really not used in a multifamily application. That's really for high temperature process type heating and cooling systems. When we take a look at also pool heating, which there are rebates on from the Cal State Initiative, that's an unglazed plastic collector, and at medium temperatures is the flat plate collector, and then for higher temperatures, that's the evacuated tube, vacuum tube system. So here we have a chart that shows, in general, how each collector is packed, in performance-wise, how each one works. You'll notice that the one that's unglazed pool collector goes up to like 86% efficiency at the zero collector inlet temperature above ambient. I mean, so a very small differential inlet to the ambient. The unglazed pool collector outperforms everything else as far as BTUs delivered, and it's also a lot less money. Usually about 1/3 the cost of a glazed flat plate collector. So when you consider pool heating systems, it's almost always going to be an unglazed pool collector. And also, just as a rule of thumb, when we size up a solar pool system, it's between 60 and 70% coverage of the square footage of the pool itself. The pool itself is a solar collector, and all we're doing is adding more square footage of the collector by having the pool collectors. And that's how we more or less figured out in general. And then the glazed flat plate collector, you notice it's not quite as high up on the collector efficiency. It's around 70%. And it goes out from left to right. This actually outperforms the evacuated tube until we get to about 120-ish degrees. The difference between the collector inlet temperature and the ambient. And so that covers the domestic hot water usage temperatures. If you really have higher temperatures, let's say you want 170, 180 degrees, and that's actually where the evacuated tube system is better. And the difference is that the evacuated tube does not feel ambient at all. The collector itself has a liquid inside, it's either water or alcohol, and it operates rather like a one-pipe steam system where when the fin is warmed up and the liquid inside turns to steam, the top part of it goes up to the header and condenses at the where the water comes through, and then goes back to the bottom of the tube and back up, back and forth. And because it's in a vacuum, it does not feel ambient, and it can be operated in either really cold weather and also doesn't reheat, doesn't lose its energy back to the atmosphere, and so it's able to elevate the overall operating temperature. The flat plate collector is not as well insulated, but it is insulated, and that's what makes it a better performer than the uninsulated collector. So it has glass glazing and insulation all around. I'm going to keep moving on because I have a lot of slides to go. It's just anything that you, we have a long ways to go, and I want to cover a lot of area. If there's things that you want to talk about, I can certainly answer it offline, or we can certainly figure out a way to do that. The SRCC rating, this is where we get the performance that is put into the CSI program. There is a computer program that's a little bit later in the slides here that you or the energy engineer or the contractor can input to determine what your projected rebate could be. For single-family residences, we have to comply with the OG 300 standards, and that is a system approach. And the OG 100 is just the collector performance, because we have to customize the system to your application, and we use the ratings of the solar collector. Some of the other requirements of the CSI program is the collectors have to have a 10-year warranty. You must pull a permit. The contractor has to be certified through the CSI program. It usually involves the contractor or owner's representative to go through the one-day training class. And also, when the unit is actually installed, your system is installed, the installation is inspected. And each contractor will at least get his first 3 inspected by a real PG&E inspector. And after that, it'll be random. Basically, metering is a BTU meter that counts how many calories or BTUs are saved by the solar thermal system. And so approximately 12 collectors or more, 4x10s that is, we would have to have a little more expense with a BTU metering system. So here's a basic solar thermal system. We have collectors on the roof. We have a tank down below. We have a solar control and basically a pumping station. When the collectors are hotter than the storage tank. The pump turns on and will circulate the colder water from the solar tank up to the bottom of the solar collector, and the solar collector will move the hotter water that's been collected back down to the solar storage tank, and it will keep circulating until temperatures get close, usually about 3 degrees, that the pump turns off when there's only a 3-degree differential, 3 to 5. Here's another view of basically the same thing with more detail. So in this case, it's a glycol system. We have either a glycol system or a drain back system. I prefer a drain back because I think it's a little more efficient, but it's a little bit trickier as far as the actual installation, meaning that we have to have everything sloped back on the roof and everywhere else at least a 1/4 inch per foot. And sometimes that can be the obstacle. But with a drain back, it's just pure water, and water transfers more efficiently than the glycol water mix. One other thing I'd like to point out is that there is a bypass between the conventional water heater and the storage tank. So that if there's something should go wrong with your solar system, you can just simply bypass the solar system and work off your conventional water heater. In this scenario, what happens is when there's when someone wants to take a shower, wash their hands, the cold water will go to the solar tank first, and that water is usually preheated by the solar system. It could be anywhere between 90 degrees and 160 degrees. And the cold water comes into the solar tank and then leaves the solar tank and preheats the conventional water heater. And by preheating the conventional water heater, it means the water heater either doesn't come on at all or comes on less. In the summertime, how it usually happens is the solar thermal systems can take care of 60 to 90% of your hot water heating load, depending how we have it sized. And in the wintertime, it's usually about 20% of what you can get in the summertime. So because the sun doesn't get up as high, and the days are shorter and it's colder outside. Here's other views of the different types of solar collectors. If you were to call me up and have me do a analysis of your system, I would use an F chart mainly to begin the process. There are other systems that are more, computer systems that are more precise, but for usually just to try to find out whether or not your project is worthy to go forward and investing more time in, I usually use the F chart to get there. And this is the CSI Thermal Calculator. It's online. You input the information into the program. This is where you can get the calculation of the proposed rebate. All right. So the CSI Thermal Calculator is free. It has to be used for the rebate program. And then you do have to go through the drop-down menus. And some that are a little bit confusing, so that there is a handbook icon up there if you want to have clarification, or you call someone who has experience doing this sort of thing to help you through the process. Let's see. I have this slide here for your reference to go back to at some point. This is a different tax credit process that you would need your energy engineer to help you with. I use Geller Energy for this sort of thing, and this helps with replacement of water heaters. If you have a complex that has multiple water heaters, this is great for a tax credit. It combines both federal and state to replacing those old water heaters with new ones, and gets a substantial amount of money back. Between the two programs, it's up to $22.50 per apartment unit. And so I have these in here. I'm not going to go into detail, but if you click on these links, you'll see that it's very interesting but very complicated. That's why you need assistance working through the program. There's also the water heaters, as far as the efficiencies, are changing we have to have more efficient water heaters given the new federal mandates. And I pulled this one up because this water heater has the best energy factor. Well, a tank type water heater will soon need to have at least a 0.62 or 0.6. This one over here will have 0.82 up to 0.87, depending on the size. And so it's to get the points and the tax credits, to having the most efficient unit out there will give you the most benefit and the most payback. When I'm looking at a solar thermal system, I look at how much load and the frequency. These are my 4 magic questions. How much space is available for the collectors? Because any one of these, and how much space is available for the storage tank? And it's how much money is available for the project. One of these things will be the limiting factor, or maybe all of them. But when I go over a project, I will look at each one of these scenarios to determine just how big of a solar system you can get. And nowadays, with the higher rebate, it actually seems to pay off better if we have more collectors and a bigger system. The current solar fraction requirement for multifamily is a minimum of 30%. And but it seems like if you can maybe have a 60%, you actually have a better return on investment with more collectors. It used to be we would just want to meet the minimal amount, but the rebate certainly has changed that. So what determines size? Hot water load, how much available for the solar collectors. There's obstructions and shading issues, and generally speaking, if it's 85% or less as far as shading, we don't really get a deduction. But once we go beyond shading, which is between 10 and 3 o'clock and during the day, if there's shading going on there greater than 15% over the day, over the course of the year, then we get deductions. All right, how large a solar tank can we fit in the site? Is there a mechanical room to try it can fit it in? And sometimes, in order to make the system work, we need a multitude of small 119-gallon tanks just to be able to fit it through the door. But ideally, we would want to have one large tank on a solar system. And ideally, we want a vertical tank. Yeah, horizontal is okay, but vertical is a better system. Is there space for collectors on the roof, or do we have to ground mount it? And then the storage tank, can we put it on the roof, or do we have to ground mount it? Sometimes structurally, the building can't handle adding the extra gallons and weight on top of the roof, but that has to be, in some cases, a structural engineer will have to do that, look into that for you. How much solar fraction does your customer want? Sometimes you may have a target that you say you want just to meet the minimum of 30%. In other cases, you might want to say, well, what's the best economically way to do this? So maybe it's 60%. And then we follow the CSI sizing program criteria. And then we also have to comply with the ASHRAE standards, although it's one of the things that as a state we need to do is to reinvent or create what the actual standards ought to be, because now with how we wash our hands and the showers are all lower GPMs, and yet we still have 1950s requirements to comply with the building code. That needs to be something that we need to, as an industry, and call the whoever your local representative is trying to get this change so that we can have smaller piping, we can have smaller sewage systems, because we're not going to be using as much hot water or cold water for that matter. Moving on a little quickly here. There are various kinds of sizing programs. All right, I'm going to do some sizing here really quickly. I'm going to do them very quickly. For the CSI program, we usually figure 20 gallons per day for the first bedroom, 15 gallons per day for the second bedroom, and 10 gallons per day for the third bedroom, and so on. And I take however many gallons that is, add it all up, and that is the gallons per day equals the demand for that day. And that's the storage tank of the solar thermal system. That's released by start. And then take that gallons, divide by 1.5, and that gets the panel square footage overall. Gallons. There's all these other types of sizing. I'm not going to go into that because it'll take too long and I don't have time. Oops, what just happened here? I don't know if I'm online or not. Okay, solar thermal sizing apartments. How much time do I have? All right. Assuming the CSI standard of 20 gallons per day, one apartment, okay, 50 unit apartment will use 1,000 gallons of hot water per day. Okay, I'm going to keep going on here. Recirculation loops are typically found in apartment complexes, and they can increase the complexity of the system design. All right, collector piping. How many collectors can you put in a row? Balanced flow. We go up to 8 collectors in a row, and that's because there is thermal expansion in the collectors. And if you put eight in a row, you actually end up with 1 inch overall thermal expansion. And if you go beyond that, then the pipes actually can be damaged. Collectors can be damaged. And the floats can go off too. It will not act like a reverse return solar piping system. And let's see. Water takes the path of least resistance. And if you notice that we come in the bottom left corner in this case and out the top right, we have to have that piping. If they go in and out on the same side, we actually have defeated the solar collection. You have to make sure that the water has the same resistance to flow and takes the same length path. And the way the system, when you do it this way, it does turn out that way. Here's a plumbing layout example. Without a pointer, I'm not really going to take time into this. Another way of doing piping and recirculation loop, domestic hot water around the building and off to your dishwashers and showers and so on. Another piping diagram. I'm just going to move over this really quickly. The main thing on these diagrams is just we have an extra pipe in there to make sure that there is proper circulation through the recirc system as well as through the tank. And it's a little bit complicated for me to talk about without a pointer. All right, controls, variable speed pumping, BTU metering, various kinds of controls, temperature differential between the collector and the tank, and high limit. So sometimes variable speed, I'll just tell you in general, the variable speed pumping does allow for a more efficient collection. The finances, I'm sure you want to get into this. Average incentive these days has been $32,000, but that's going up because of the new rebate program. These are some of the costs that are or the considerations we put into a financing program. This chart shows step 1 and 2, and there's actually step 3 and 4 I didn't show here, but just for simplicity, we're only dealing with step 1 and 2. And you'll see what's current, and what will happen in the next week or so is the what's called the new. And the current one for a multifamily generally has been $14.53 per therm stage displaced per year, and the new is $20.19. And if it's low-income housing, then you get even more, almost $25. So here is an example residential, and then commercial up to $800,000 in our project. A pool heating system, and then some of the data that we have as far as jobs have been done. Let's see. There is a federal tax credit of 30%, and that is actually due to decrease in a year and a half to 10%. So I would suggest you call your congressman to see if they can extend it. It's been 30% since Jimmy Carter. Depreciation, this is all good information here, but see your tax accountant when applying it for our application. So there's an example I have of a 24 by 10 system, and it costs about $131,000 to the job installed here up in Northern California. And this was the using the new rebate amounts of almost $40,000, and then the tax credits and depreciation. So the amount that's actually used is looks like you're looking around a 7-ish year payback, return on investment. Here's some websites to visit to help in helping you decide what you want to do, and calculations and resources. And domestic hot water recirculation. The reason why I have this in here is because there are, in addition to recirculation, there are other things that have to be considered. You know, hot water is about 14% of our household energy use, the second or third largest within our residential energy pie. And then there's the weighting. I just want to touch on a few things besides recirculation. To save water, we can change out the shower heads. A lot of them are not have their flow meters taken out of them, and it is a serious situation. We really do have to. We're mandated to reduce our water usage by 25%. And as a landowner, how can you do that? One is make sure you have a recirc system on it. Other one is shower heads. Water pressure plays into a factor on this. When they say the 2 gallon per minute shower head, that's figuring at 60 psi. If you are only delivering 40 psi, I assure you're not getting 2 gallons per minute out of a shower head. So if you want to play around with that, you can do that. Faucets, I mean, you just go around the apartment complexes and turn the faucet to see how much GPM comes out of it. Commercially, it's half a GPM is the new standard. Tub and shower diverters. When you turn on you take a shower and you lift up the diverter, and not all the water, and some of the water is going down the drain through the spout and not up to the shower, you're actually literally losing that water straight down the drain. And here's a very simplified system where we have balancing valves between one floor and another floor, and a recirc system. And typically what I find out there is that there's, on the recirc system, there's a recirc loop, and there's a manifold, and off the manifold, there's another 15 feet or so that goes to the shower or faucet. And if you want to increase the amount of savings, you could install something like this hot link bypass valve at least one apartment per apartment. And this will actually have instant hot water at the fixture. If the unit has to wait a long time for hot water, even with a recirc system, something like this will give them hot water right at that fixture instantaneously. It's not electric, and it's has a little thermal disk inside. We'll maintain about 110 degrees inside there. Here's a little bit of information as far as BTUs. That can be gallons per that can be saved per unit, and then on the drain and water side, and so there's savings that can be done at your end. All right, I'm going to turn over to questions now. confuse them, but it really does come down to here's a bunch of information, and there are energy engineers and contractors to consult with for your particular application. And I'm usually the person in the background assisting some of these contractors and engineers.
Attendees. What we will do, though, is send out this presentation along with the recording and include John's contact information so that if after you digest all this information and you do have questions, you'll be able to get into contact with him or with Build It Green following this presentation. And with that, I would like to thank John Gross for his time and his expertise on solar thermal net zero energy equipment. I'd like to thank everyone else for attending this webinar. Few upcoming webinars, but the most upcoming webinars are going to be happening on May 7th at 2 o'clock. We're going to have a webinar on energy management in multifamily buildings. This is going to be presented by Samara Larson from Seed Partners. In addition, the following Tuesday on May 12th at 1 p.m., we'll have another webinar on passive house, building a renewable-ready California with Graham Irwin, a leading expert in the passive house design and technologies. Attendees. Thank you all. We will see you next time.